2001 marked the completion of White Sands Missile Range testing, paving the way for the evolved Sea Sparrow missile to transition to the international at-sea test firings from the self-defense test ship. At-sea testing of the ESSM against the threats defined in the International Threat Document resulted in significant advancement of the missile design and confirmed of the capabilities of the ESSM to successfully acquire, guide on, and destroy low-altitude subsonic and supersonic inbound weaving and diving threats. The unique self-defense test ship typically operates 85 nautical miles off the coast of California in the Fleet Support Test Range, which provides a realistic at-sea shipboard environment. Unmanned and remote-controlled, the self-defense test ship, along with its installed weapons and sensors, provides the ability to fly targets within 300 feet of the ship, vice the normal 12,000 feet offset required for safety on manned ships. The self-defense test ship's combat system utilized air search radars and the standard configuration re-architectured NATO Sea Sparrow surface missile system with 2 tracker illuminators and 1 Mark 29 guided missile launching system in support of ESSM testing. Subsonic BQM-74 drone, Harpoon target, and supersonic Vandal targets represented real-world anti-ship cruise missile threats. Proved lethality of the ESSM, a prime objective of at-sea testing, was validated by successful destruction of these representative threats. All missiles used for these firings were production representative assets. A significant change in missile design resulting from at-sea testing was the relocation of the rear reference antenna from the control actuator assembly to the guidance section. This negated the adverse effects of rocket motor burn on missile guidance. The inherent design versatility of the ESSM was key to continuing the test program. Combat operations were standardized, documented, and rigidly followed throughout the at-sea test phase. In addition, prior to each event, combat system performance was baselined and recorded. This consistency was required to effectively remove the combat system from the ESSM evaluation equation and facilitated the analysis of missile performance. Initial testing began with the engagement of a single radial inbound subsonic sea-skimming BQM-74 drone. The ESSM was automatically launched per plan, guided to intercept, and destroyed the target. This was followed by a very low-altitude weaving threat scenario, again using the BQM-74 drone, executing a bathtub weave. The event resulted in a success as indicated by telemetry analysis. The telemetered missile passed very near the target in the weave, well inside the required lethality region. These successes set the stage for the engagement of a radial inbound sea-skimming supersonic Vandal target. While this event was the most challenging to date, ESSM again easily destroyed the target. Another Vandal was used to represent a high-diving supersonic threat. The target was detected, tracked, and passed for evaluation and designation. The tracker illuminator received the designation, acquired the target within 1 second, and supported the automatic missile firing. The ESSM guided to the diving target and successfully destroyed it while in the 30-degree dive. A dual missile salvo firing using standard salvo spacing was conducted against a sea-skimming supersonic Vandal executing a 10G horizontal weave. Both missiles guided within the lethal range of the warhead, demonstrating the capability of the ESSM to successfully engage this threat. An air-launched subsonic sea skimmer was represented by a Harpoon target. For this test, the combat system supported the pre-planned automatic firing of a single ESSM, resulting in the destruction of the target. With completion of the international portion of the self-defense test ship firings, the ESSM program has moved on to the next phase of testing. This includes U.S.-only firings from the self-defense test ship, as well as the first-of-class ANZAC qualification events. Soon to follow will be the Royal Netherlands Navy and Federal German Navy APAR firings. The U.S. Navy will also conduct firings to fully qualify and formally accept the ESSM for service use on Aegis-class ships. On July 23rd of 2002, the first fleet firing of ESSM occurred from the U.S. Navy's newest Aegis destroyer, the USS Shoup. This successful event confirmed ESSM integration into a fleet unit and paved the way for operational evaluation in 2003.